Deploying schema changes to production is terrifying. One wrong move and customer transactions fail, revenue stops, and rollback becomes impossible. This is a practical walkthrough of zero-downtime migration patterns for production systems. You'll learn the expand contract pattern, how to handle dual rights during migrations, and why databases need fundamentally different deployment strategies than application code. We're covering the exact techniques companies use to change schemas while customers are actively using the system. When you push bad application code, you can roll back in seconds. But databases are stateful. If a schema migration corrupts data or breaks an index mid-transaction, you can't just undo it. Customers are actively writing data while this is happening. A failed column rename could cascade into thousands of failed payments, and by the time you realize something's wrong, you may have already transformed data in a way that makes rollback impossible. Application servers are cattle. If one dies, spin up another. Databases are pets. They hold the only copy of your customer's transactions, order history, and account balances. Multiple microservices read from the same schema, so one breaking change ripples everywhere. And when you're adding an indexed column to a table with 2 billion rows, that's not a 5-second deploy. You're looking at a 6-hour lock that blocks every write day into that table. Here's the pattern that makes zero downtime possible. Expand contract. Instead of ripping out the old schema and replacing it in one terrifying deploy, you do it in 3 deliberate steps. Expand. Add the new column or table right next to the old one. Migrate. Start writing to both places simultaneously while you backfill historical data. Contract. Once every service has migrated over, tear down the old schema. At every single step, your application works with either the old schema or the new one. Let's walk through a concrete example. You've got a users table with a full name column, and product wants to filter by last name. Classic schema mistake biting you later. Phase 1 is expand. Add first name and last name as nullable columns. Notice they're optional. That's critical. Your existing code doesn't know these columns exist and doesn't care. Old services keep writing to full name. New deploys can start populating the split fields. Everything coexists peacefully because you haven't removed anything yet. Now comes dual writes. Update your application code to write to all 3 columns. The old full name and both new split fields. Deploy this everywhere first, let it run for a bit, then backfill historical data. The critical order is code deployment before backfill. Why? Because the moment backfill starts running, you need every running instance writing to those new columns, or you'll create gaps in your data. Get this backwards, and you've got a corrupted dataset that's genuinely painful to reconcile later. Once dual writes are deployed, you can start backfilling. Notice we're doing this in batches, 10,000 rows at a time, because locking an entire users table is a great way to take down production. Run this query, check your monitoring, make sure nothing's on fire, then run it again. Rinse and repeat until the where clause returns nothing. Yes, it's tedious, but when you're dealing with customer data in production, boring and safe beats clever and fast every single time. Now comes the scariest part, removing the old schema. First, switch your read queries to pull from the new columns. Deploy that. Watch your error rates for a few days. If everything looks clean, then you can finally drop that old full name column. Wait actual calendar days between these steps. I know it feels slow, but if something breaks, you want time to catch it before the old data is gone forever. The contract phase isn't where you rush, it's where patience saves your job. Dual writes are the technique that makes all this possible. Every time you write data, you write it to both the old and new system simultaneously. This is your safety net when strangling a monolith or switching database technologies entirely. But here's the gotcha. What happens when one write succeeds and the other fails? You've now got inconsistent data. Some teams handle this with queues and eventual consistency. Others accept that rollback means manual cleanup. Either way, dual writes will slow you down. That's the price of safety. Here's what dual writes look like in practice. Notice we're writing to the new database first, then the legacy one. Why that order? Because if the new system fails, you want to know immediately. Don't wait until your migration is complete to discover your shiny new database can't handle production traffic. The catch block here is critical. When writes diverge, you need a paper trail for reconciliation. Some teams run nightly jobs to compare both databases and fix inconsistencies. It's tedious, but it beats waking up to silent data corruption. Blue-green deployments are the gold standard when you need an instant escape hatch. You're running two complete environments. Green is shadowing blue through replication. You apply your schema changes there, let it catch up, then flip the switch. Traffic moves atomically. If something breaks, you switch back in seconds, not hours. The downside? You're burning double the infrastructure cost during migration. But when you're changing core tables that touch every transaction, that insurance policy is worth every penny. None of this matters if you can't track what you've deployed. That's where Flyway and Liquibase come in. They treat your schema like application code. Every migration is a versioned file that runs exactly once, in order, tracked in a metadata table. When you push to production, there's no guessing whether that column exists or not. You've got an audit trail showing exactly what ran, when it ran, and on which environment. When something goes wrong, you know exactly which migration to reverse. Let's talk about how GitHub pulled off one of the gnarliest database migrations in recent history. They needed to move GitHub.com to entirely new MySQL infrastructure, without dropping a single request. Their approach? Dual write everything to both databases, then use their scientist library to compare results in real time. Any discrepancy gets logged and fixed. Then, they slowly dialed up red traffic to the new system, monitoring the whole way. This took months, but millions of developers kept pushing code without ever noticing the ground shifting beneath them. Stripe had an even gnarlier problem. They needed to go from a handful of database shards to thousands while maintaining 5 nines of uptime. You can't take down payment processing to shuffle data around. So, they built an entire data movement platform that handles migrations transparently to their API clients. The system coordinates dual writes, replicates data live with consistency checks running constantly, and migrates one shard at a time. The big takeaway? At scale, you need automation and observability baked in from the start. Here's what this all boils down to. Backward compatibility is non-negotiable. Every change needs to work with both old and new code running simultaneously. Test on real production volumes, because migrations that fly on dev data will choke on billions of rows. Watch lock durations like a hawk. Use concurrent index creation religiously. It's slower but non-blocking. And never drop columns until the old code is completely gone. Keep that old schema around for at least a week so you've got a rollback path if things go sideways. Let's talk about the gotchas that'll bite you at 2 a.m. Adding foreign keys without the concurrently flag? Full table lock. Say goodbye to writes. Changing a column type triggers a complete table rewrite. And the classic, dropping columns while old code is still running. Your replicas are also a landmine. Writes might succeed on the primary, while lagging replicas serve stale data. The pattern is clear. Slow down, validate your backfills, and actually test your rollback plan before you need it in production. Which strategy should you reach for? Expand contract is your default. It's the simplest, lowest risk option for typical column changes. Blue-green is when you're doing something scary like completely restructuring your schema and you want that instant abort button. Dual write is the heavy artillery for moving data between systems or breaking apart a monolith. The mental model is simple. Start with expand contract. If you find yourself getting nervous about rollback complexity or you're touching multiple databases, escalate to the more sophisticated patterns. Let's wrap this up with what actually matters. Databases hold state, so you can't just YOLO a schema change like you would deploy application code. The expand contract pattern keeps you safe. Add first, migrate data, then remove. Backward compatibility isn't optional. Your old code has to survive the new schema, even if just for 5 minutes. Test against real data volumes, automate everything with migration tools, and never skip steps. Database migrations reward patience and punish shortcuts every single time. Here's your checklist before you touch production. Bidirectional migrations aren't paranoia. They're your escape hatch when things go sideways at 2 a.m. Test on realistic data volumes because a million rows behaves nothing like 1,000. Deploy that backward-compatible code first, then run your backfills in batches, not one giant transaction that locks your database for an hour. Monitor everything, especially replication lag. And that old schema you're dying to drop? Wait at least 2 weeks. I know it feels slow, but slow is smooth, smooth is fast. Speaking of deliberate migrations, the Strangler Fig pattern takes this philosophy even further. Watch that deep dive next to see how you gradually replace entire systems without a big bang rewrite.